All right, buckle up everyone, because today we're diving into some serious AI territory. We're talking about AI that can actually tackle complex math problems.
Not just like basic arithmetic, right?
No, we're way past that. Think reasoning, logic,
Uh,
even using tools like code interpreters to help them along.
Now that's what I call pushing the boundaries. What's really got me intrigued is how this research is changing the way we even think about AI training. It's less about stuffing the AI full of facts and more about
Teaching it how to think.
exactly how to approach problems, how to break things down, like a human mathematician would.
So it's about the process, not just the answer.
Exactly.
And that's where this paper, Building Math Agents with Multi-Turn Iterative Preference Learning, comes in. They're exploring this idea of preference learning.
Okay, so break that down for me. Preference learning. What's that all about?
Well, it's kind of like, imagine instead of just giving the AI a textbook and saying, memorize this, you have a tutor who's there every step of the way.
Oh, I see. So giving feedback, guidance, not just checking the final answer.
Right. It's about teaching the AI what humans consider a good solution, not just a technically correct one.
Okay, that's interesting. So how did they test this out?
They use these popular datasets, GSM8K and MATH. GSM8K, that's all those grade school math problems we all love, or maybe try to block out of our memories.
Oh, I remember those. Fractions, percentages, like the good old days.
And then math, that one goes deeper into the fun stuff like algebra and calculus.
Ambitious. So what they find, did this preference learning thing actually work?
Well, the results are pretty impressive. They saw some big jumps in accuracy. Like on GSM8K, they went from 77.5% to 83.9%.
That's a significant jump. What about math?
On math, they went from 46.1% to 51.2%. Not as big, but still.
Still a noticeable improvement. But I gotta ask, are we maybe getting a little ahead of ourselves here? Is this really as revolutionary as it sounds, or is there some hype mixed in?
That's a great question. And to be honest, it's healthy to be skeptical. I mean, every new research paper claims to be a breakthrough. But I do think there are some important things to consider here, some potential limitations.
Okay, I'm all ears. What kind of limitations are we talking about?
Well, for starters, how much of this success is tied to these specific data sets? GSM8K and math are great, but they're still just a slice of the vast world of mathematics.
So it's like training someone to ace a particular test. They might get a perfect score, but can they actually apply that knowledge in the real world?
Exactly. And that brings up another point. The paper focuses a lot on accuracy, but human mathematical reasoning, it's about so much more than just getting the right answer.
It's about understanding the concepts, being able to explain your logic, being flexible, adapting to new situations.
Right, so just because an AI spits out the right answer doesn't mean it's thinking like a human mathematician.
Absolutely. There's a depth there that goes beyond just calculation.
So while the findings are exciting, we need to be careful about overstating their implications.
Okay, I'm with you on that. So we've talked limitations, but what about strengths? What parts of this research really stood out to you?
Well, I think one of the most compelling things is this multi-turn iterative process they use for preference learning.
Multi-turn iterative process. Sounds a bit technical. Can you unpack that a bit? What does that even mean?
Sure, so basically, it means the AI doesn't just learn in one shot. It goes through these rounds of solving a problem, receiving feedback, refining its approach, then doing it again and again.
So it's like this constant back and forth, learning, adjusting, improving.
Exactly. And this iterative approach, it's crucial because it allows the AI to gradually align its thinking with human preferences, which is, well, the whole goal of preference learning.
So it's not just programmed with a set of rules, it's actually learning to adapt based on feedback, kind of like we do through experience.
Precisely. And that's what I find so fascinating. It's not just about building AI that can solve math problems. It's about building AI that learns like we do.
Pretty mind-blowing stuff. But, okay, so we have this AI going through these learning rounds, but how does it know what a good solution actually looks like? How does that feedback work?
That's where these two key algorithms come in, MDPO and MKTO.
All right, those sound a little intimidating. Can you give me the layman's terms version? What do they actually do? Okay, so imagine MDPO as like a coach, right?
Yeah.
They watch you play, analyze your moves, and point out where you can improve.
Oh, I get it. So it's looking at the difference between, say, a really elegant solution and a kind of clunky one.
Exactly. It helps the AI see where it went wrong, where it could have been more efficient or clearer.
So it's not just about getting the right answer. It's about getting there in a way that makes sense, that a human would understand.
Right. Now, MKTO, that's more like having a teammate who's like, hey, why not try it this way? Suggesting different strategies.
So pushing the AI to think outside the box, to explore different paths to the solution.
Exactly. It's about encouraging that creative problem solving that we humans do so well.
I'm really starting to see how these two algorithms work together. It's like this dynamic duo guiding the AI toward more human-like thinking.
And the paper really emphasizes that this iterative process with MDPO and MKTO working together, it's essential for effective preference learning. It's not a one-time thing, it's this constant refinement.
It's like learning to play an instrument or write code. You don't just nail it on the first try, right?
Yeah.
It takes practice, feedback, and this willingness to constantly tweak and improve.
Right. And even with all this back and forth, the researchers did find some limitations. Like as the AI got better, it could sometimes fall into the trap of just memorizing answers without really understanding the concepts.
So it's like that student who crams for the test and gets a good grade, but then a week later, poof, it's all gone. They didn't actually learn anything.
Exactly. And that tendency to memorize rather than understand, that's a big challenge in AI research. It really highlights how complex it is to build truly intelligent systems.
So how do we address that? How do we make sure the AI is actually learning and not just becoming a superpowered calculator?
Well, that's where the diversity of training data comes in. If the AI only sees a limited set of problems, it's more likely to rely on memorization. But if you challenge it with all sorts of different problems from different areas of math.
It's like the more you learn, the more you realize you don't know.
Yeah,
It forces the AI to develop a deeper, more flexible understanding.
exactly. And I think that's an area where this research could be expanded. They use those established data sets, but imagine what they could achieve with even more diverse, more complex data.
So pushing the AI out of its comfort zone, giving it more to chew on. But data diversity, that's just one piece of the puzzle, right?
Yeah.
What other areas for improvement or future research do you see?
Well, remember how we talked about the paper focusing a lot on accuracy as the metric for success?
Yeah, and how human reasoning is about so much more than that.
Right. So I think expanding those evaluation metrics would be really interesting, looking at things like how elegant the AI's solution is, whether it can explain its logic.
So moving beyond just did it get the right answer to how did it get there and can it tell us why?
Exactly. Another thing to explore is the role of human feedback. The paper kind of assumes this ideal scenario where the feedback is always accurate and consistent.
But let's be real, human feedback is messy. We're subjective, we're inconsistent, sometimes we're just plain wrong.
Exactly. So figuring out how to make preference learning more robust to those real-world complexities, that's crucial for any practical application.
So it's not just about the AI learning from us, it's about it learning to handle our imperfections, our quirks. That's a tall order.
It is, but it's also a really exciting challenge. I mean, if we can pull that off, we're talking about AI that's not just smart, but also adaptable, resilient.
More human, in a way.
Yeah.
This has been a fantastic deep dive so far. We've gone from the technical details to the philosophical implications, and I think it sets us up perfectly for what's coming next.
Right. In the final part, we'll be taking a closer look at those real-world implications. How could preference learning change the way we learn, the way we work, the way we solve problems?
All right, so we've talked about the potential, the limitations, the ethical considerations, but where does this all lead us? What does preference learning actually do out in the real world?
Well, think about education, for example. Imagine a world where every student has a personalized AI tutor, not just some program that grades quizzes, but something that truly understands how they learn, adapts to their pace, their style.
A tutor that knows when a student's struggling maybe suggests a different approach, almost like a human teacher. It's a pretty amazing concept, but wouldn't that just widen the gap between those who have access to this kind of technology and those who don't?
You've hit the nail on the head there. The potential for good is huge, but we have to be incredibly mindful about equitable access, about responsible development. Otherwise, we could end up making existing inequalities even worse.
It's a reminder that tech alone isn't the answer. We need to think about the human side of things. Fairness, access, making sure everyone benefits. What about other fields? How could preference learning impact something like scientific research?
Oh, the possibilities there are immense. Imagine AI that can sift through mountains of data, spot patterns that humans might miss, even propose hypotheses. Think drug discovery, new materials, climate modeling. These are areas where progress can be painfully slow.
So we're talking about speeding up scientific discovery, but what does that mean for scientists themselves? Do they just become obsolete?
I don't think it's about replacing human researchers, but more about augmenting their abilities. The AI can handle those massive data crunching tasks, freeing up scientists to focus on the big questions, the creative leaps, the stuff AI might not be able to grasp.
It's like a partnership, each playing to their strengths. Still, even if it's collaboration, not replacement, doesn't that raise concerns about jobs?
Absolutely. It's a valid concern and one we need to be proactive about addressing. As AI takes on more tasks, we have to think about retraining programs, supporting people as they transition to new roles, maybe even rethink the very nature of work itself.
It's like technology changes and society has to adapt. We can't just celebrate the shiny new tools without preparing for the ripple effects.
Exactly. Open dialogue and careful planning are crucial. We need to anticipate the consequences, both good and bad, and put systems in place to ensure that everyone benefits from these advancements.
This whole deep dive has really been eye-opening. It's not just about AI doing math, it's about reshaping how we learn, how we work, how we solve problems as a society. And that's a pretty big deal.
It really underscores that as AI gets more sophisticated, the key question isn't just what can it do, but how do we make sure it's used for good?
So to our listeners out there, here's a thought to chew on. As AI gets smarter, are we getting smarter about how we use it? This isn't just a tech issue, it's a human one. Stay informed, stay curious, and stay engaged in shaping the future we want to see.